vitreous, ¿no? Es una palabra peligrosa, porque si no la pronuncias bien suena horrible. Esa es la cirugía, esa es la imagen de la cirugía de él.
Sí, doctor. ¿Verdad, verdad?
Sí.
Tuvo un dedo inferior, superó en enero, tiene múltiples agujeros y colocó en la nota quirúrgica vitro patológico, banda inserción baja y ancha.
Chévere. Okay, gracias. This is the draw of the last surgery we did in January. He had a retinal detachment surgery in January. So this is what we did, and this is the draw of what was at that moment and what the procedure we did to do the surgery. So right now we put the silicone oil in January, and we're gonna extract the silicone oil. You have to extract always the silicone oil, because if you leave the silicone oil there, it emulsifies with the water of the eye and it causes glaucoma.
Permiso, doctor Smith.
Dele.
Por apelar, diga, Don Miguel, compañero presente, paciente de nombre Arsenio Felipe Alarcón, tiene 37 años de edad, retira aceite de silicona en el ojo izquierdo por 2 puertos.
Chévere, gracias.
Muchas gracias.
Gracias.
Aceite es de 5.000.
Sí, claro.
O pro grabar video.
So this is through this hole here, we're gonna put this pipe here and this tube, and that fills the eye with water, so we can have a water silicone exchange.
So what does this silicone really do, the silicone oil?
The silicone oil helps us to keep the retina in its place till the laser, the scars of the lasers attach firmly to the retina. You put laser on the tissue under the retina, and this burns that tissue, and that causes a scar. This scar, it's what attached the retina. So this scar, to form the scar, the process is between 1 or 2 weeks. So in the meantime, both tissues has to be, being held by something. So we work with different type of fluids or gases, taking in count the tension of the surface of every chemical product. So water has a surface tension different as air, as some different type of gases that we use, and silicone, and some different type of silicone densities. If we use gas, the gas stays in the eye depends on the gas. We use 2 gases, SF6 and C3F8, I can tell you what it is after that, but for instance, SF6 lasts in the eye 10 days. So the bubble of the gas is getting each time smaller and smaller, and the gas is being replaced by the water that the eye produces. So we use the gas to seal the hole in the meantime that the laser is creating the scar to holding it firm. So the gas has to be positioned in exactly where the hole is. For instance, the gas is lighter than the air. So if the hole is up, the patient has to be sitting so the gas goes up and seals the hole. If the hole is behind or down, the patient has to be to the face down, you know, to keep the gas sealing the wall. So if we have silicone oil, the surface tension caused by the oil, it's a little bit better than the water, and it stays there. So if we have water or liquids under the retina, we can find the hole and fill the eye with silicone oil. In this case, for instance, you have plenty of holes. You have 5, 6 holes. You can see the holes over there. And there are plenty of holes all over around. So since there are holes in the upper part of the retina and the lower part of the retina, the physical dynamic of all the position of the holes are very important on what fluid we choose to seal the retina and what time and every single patient. You
So
know.
very location, size.
The location, the weight of the
fluid and the surface tension.
correct, the age of the patient, the location of the hole, all the condition of the patient. It's one hole, there are multiple holes. It's one upper hole, it's very easy. The patient's going to be sitting. If there are holes all over around, so and an elderly patient or overweight patients that you don't know that they won't keep the position, so you won't have the results because the patient's going to be moving. So it's a pretty dynamic choice you have to make in every single case, right? So, dame el otro puerto. Tengo visitas, así que estoy contándole a la gente en inglés, Arsenio, lo que está pasando, ¿verdad? This is a 23 gauge entrance. This is called transconjunctival 23 gauge. You don't need to suture this wound here because it's small. It's a self-sealing transconjunctival hole. This one here, it's a 20 gauge. 20 gauge in diameter, it's 0.9 millimeters diameter, something like that, somewhere there. And it's it's a bigger hole, tube. So when dame la pinza azul, when we take this out, it's gonna be leaking. That's why most of the cases we need to suture it. This one here. Look, this is the oil coming out. You see? Mm-hmm. Look how it is.
Very viscous.
Very viscous, okay? So take this out, it's a pain in your back. Dame un poquito de agua, con agua mejor. ¿No? Bueno, eso es para, ya tú me diste, yo pensé que era para lavar la córnea. So, here we go. This is the way we do it manually. You see, with this syringe, I put the syringe here, and then I start suffering. Look at my hands. Look at how slow it's coming into the syringe.
So you're pulling out the
You cannot imagine how difficult is this. Levanta un poco. So if you find a way to build something that you can connect to that point and look.
But the way you're pulling and pushing, it's very controlled. It's very slow.
Well, it has to be, yes.
So you're
It's not only slow because I want it, because look at the ambulance here. Look at the negative pressure that I'm doing inside the syringe. You see? You have look, all this, that's 10 minus 10 millimeters that I'm doing here, and look how slow it comes out. So I will be there, my fingers will be blue, and I'll be here in 5 minutes. And my hands will be shaking with all the force that I'm doing right now.
So it's very high force, but at a slow speed.
Yep.
So those would be the major design criteria to
Yep.
do it.
You can simulate this condition in a lab very easily, you know?
Yes. So if you know the material type,
Mm-hmm.
does anyone study like the pressures that you are supposed to be using? Is there any
I'm not. I don't know the pressure that I'm doing now, the negative pressure that I'm doing now, but believe me, it's a lot. Look at my fingers. Come and take a look at my fingers here from outside. You see how what I'm doing, right?
Yeah. So you almost are doing like 10 millimeters in, how long did that take you? A solid 30 seconds?
No.
You can estimate it from there.
It takes 5 minutes or more.
5 minutes to do how many full 10 millimeters?
1 cc, well, 1 cc, couple of minutes.
1 cc, about 5 minutes.
Couple of minutes.
What we can get as an engineer is a flow rate, and from there I can estimate what negative
Correct.
pressure you're doing.
Correct.
That's a quick match.
Well, help you think, be like, oh yeah, I could just do that. And if you know the material type, you know the density, and insert that into your
Yeah.
equation.
20 gauge hole, 5,000 centistokes silicone oil, and the total volume is between 5 and 9 cc's, depends on the length of the eye. Big eyes, myopic eyes, or they carry more silicone oil.
Do you know about how much you have to use for those?
How much what, excuse me?
How much, what volume you have to use for
Between,
those?
it depends on the eye, between 4.5 cc's, 5 cc's, till 9 cc's. Cubic centimeters, millimeters. It's not only the time that takes, that's the effort it takes, and as I said, they are silicone extraction kits, but built to some machines. But you have to buy a $125,000 machine to have this. You see how slow the bubbles are coming in? Then you will see slowly how the edges of the bubble, inner bubble of silicone oil, appear behind the lens through the dilated pupil. You will see the...
And so you have to slowly pull out all those bubbles?
You'll see the edge in the left side of the pupil. You'll see the edge of the bubble. Look, that's half silicone. The right side, it's silicone oil. The left side is the water that I'm putting in to replace the oil. You see?
There it is.
Oh, I see.
There, you see it, right?
It's in the middle?
It's in the middle of the line right now.
So at very specific places you have to put oil.
Yeah. There you see the bubble. It's a spherical bubble.
Oh, I see. Oh.
And so you have to pull up or are you pushing down? Just pulling up.
Both. So, like, I think it was
These are two spheres. The eye is a sphere, and the silicon bubble is a smaller sphere moving inside.
almost, is it at the edge?
It is, yes, it is almost out.
Ahí se pone.
Almost.
It's okay.
You see the edge of my tip,
Yeah.
and how now I'm gonna move it to, it's one sphere inside the other sphere, so it's a hidden part of this. I see, I have to look for it. You see it there, right?
Yeah.
Oh, I see. Behind.
It's behind the tip of my instrument. So what I do now to avoid this, dame por favor la pinza azul. No lo botes.
Okay.
Look, this eye,
Can you show it? Can you show it?
look. See?
So that came out of the eye.
Yes.
It's a lot. Large volume.
Well, it's water
It's a
and look, here I'm gonna move this from one side to the other so I can take this rest of silicone out of the eye. You see? How that's what I call tension of the surface. Look how the silicone bubble is attached to the metal cannula. You see? Because of the adhesive power. And that's the property, physical property that we use of this oil to keep the retina in its place. So you see right now that the bubble is very small, and it's not in the edge of the cannula. But right now I'm gonna go inside the eye and see how is the retina after I took the silicone out. So I'm gonna change the setting of the microscope and use a light to go there and see with my camera what's going on. There is still the retina in place or not after the retinal surgery. And I'll do something that you see so you can see how the lens is gonna be opaque. As I told you before, this is a 128 diopters lens. Dame viscoelástico para poner en la córnea. So the focal distance between the lens and the cornea, it's 10 millimeters. So when I get both lenses closer, the lens to the cornea the distance is less than 10 millimeters, and then the lens fogs, gets opaque, right? So look. Look at the lens. You see?
There you go.
I'm gonna focus on the lens. You'll see. I don't know if it's possible. Yes, it is. Look at the lens. Look at the dirt of the lens. You see?
Oh,
When
yeah.
the distance,
Very dirty.
yes, when the distance between the lens and the cornea is short and small, then that's what happened to the lens. Then you have to, no te muevas, then you have to, when you move it away from the cornea, it clears. But when you have to work, you put the lens down. It gets again. Está golpeando aquí, ya va. Vamos a ponerlo aquí para que ellos vean. Look. Ahí échale aire. Échale aire. Look.
So you have to fan.
Ahora páralo. Look.
Yeah, and they're together.
Bob. No, para el aire. Deja de echar aire tú.
So is that for the heat that you just get, or just to get the?
It comes air from the nose of the patient or something, and you'll see the bubbles and the spots over there.
So it's fogging it up.
It's fogging, yeah. Look,
And so you fanning it helped it
from
unfog.
outside, yeah.
So that's why you want a fan.
That's
to
what I want to
replace the
fan.
top of the microscope
Look,
that you can
look,
use
look,
as a tube
look,
on it.
look. Espérate todavía un poquito. Ahora dale con la mano al ventilador. Dale, échale aire. Look there. You see?
So if you can look on the screen, you see it gets clearer.
Exactly. So simple.
So you just want a fan that goes at different speeds
This, so when I take this out, I will take this bubble, this part of the bubble out. Vamos a ponerle un poquito de aire. That was the rest of it. Okay? I want you to touch the oil right now so you can see the density of the oil. Look, this is a little bit silicone oil. So the air right now, the eye is right now half liquid, half air. Why do I do this? So I'm taking this out, and the air, it will help me to seal the wounds from inside. I don't know if I'm explaining myself. So look, I'm taking this out slowly, and you will see the remains of silicone oil going out there. The eye is literally spitting the rest of the silicone oil out. You see? Look.
Yeah, it's like a little volcano.
Correct. So there it goes, a little bit more. This is oil. Take it slowly out. That's it. So as you can see, there is no air under the conjunctiva here. Why? Because the wound is sealed. Why? Because inside the eye, where the wound is, it's air and not liquid. If it's liquid, we will have, for sure we would have leakage here, okay? And a bubble under the conjunctiva. So this is why the physical property of the different elements help us to seal the wounds. So right now I'm taking this out from the eye quickly, and this second part is sealed, and that's it. So this is, dame un cotonete. I can show you in the camera. What is this made of? This is the tube that we use to work inside the eye. You see? Mm-hmm. This here is 23 gauge. And this silicone part of the tube, it's a valve. It's a unidirectional valve that we use so things can get in and not out.
So bidirectional valve.
Well, bidirectional in terms that you can go inside the eye with an instrument, but what you're putting inside the eye is not going through that valve out.
So that's what you mean by unidirectional.
It's one directional valve.
Unidirectional valve.
Unidirectional valve, yes, correct. And that's it. So this is why the eye keeps with pressure, and we don't need to seal or suture the wounds because of the size and because of the elements that physical property of the elements that we're using. And that's it. So you saw two differences or two interesting things. Mm-hmm. How this lens is getting fucked with the heat that it's generated here and the hot air. Mm-hmm. And the temperature of the eye. Remember that the temperature of our body is 37 degrees Celsius. So, and here we are 12, 14 Celsius. So the body, the eye is generating heat. When you use this lens close to the cornea, it's, folks, like a windshield of a car. Exactly the same.
Mm-hmm.